You type out a text message, and before you even finish, your phone guesses the exact next word you want to use. We see it every day. It feels simple. But modern AI models have scaled that basic predictive trick up to the point where they can draft legal documents, they can compose poetry, and write entire essays. This technological leap is powered by a specific architecture called the Transformer Decoder. It is the core system inside GPT-style models. While it sounds like science fiction, there is no magic happening inside the machine. It operates as a highly logical, strictly organized digital assembly line. Let's walk the factory floor. Every factory needs raw materials. For our example, we are going to feed the model a very brief, simple sentence. I am happy. This diagram outlines the exact path our sentence will take. You can see the flow moving from the bottom up, starting with our text at the base, entering the embedding phase, and traveling straight up into the decoder blocks. But right at the start, we hit a roadblock. Computers have no concept of the English language. They process numbers, and only numbers. Before the system can guess what word comes next, the very first step on the assembly line must completely strip away our human language and translate it into a purely mathematical format. That translation happens in the embedding step. Here, a word like happy is converted into a complex list of hundreds of numbers. Think of it as a highly detailed mathematical barcode that captures the word's exact definition. There is a flaw, though. We now have distinct barcodes for I, am, and happy, but they are floating freely. The computer has no idea what order they belong in. To solve the order problem, the assembly line uses a clever trick called positional encoding. Positional encoding permanently stamps each mathematical barcode with a sequential timestamp, 1, 2, 3, so the system knows exactly where that specific word stands in the line. Now, our raw data is prepped. The model knows the definition of the words, and it knows their exact chronological sequence. The deep analysis can begin. Looking at this detailed schematic of the decoder block, we enter the most critical processing room in the entire factory, the multi-head attention layer, highlighted right in the center. Attention allows each word to look around. As the model processes the word happy, it actively scans the other words in our sequence to figure out who exactly is feeling that emotion. This step tells the model exactly how much importance to place on those connections. It mathematically highlights who or what the sentence is currently focused on. This attention mechanism gives the system a holistic, contextual understanding of the phrase. It evaluates how every word influences every other word. This schematic shows where the contextually mapped data goes next. Above the attention layer, it enters a feed-forward neural network, followed by layer normalization. The feed-forward layer acts as an independent mini-brain for each individual position. It processes new relationships from the attention layer to add deeper meaning to the data. But heavy processing introduces a risk. As the data gets altered and mathematically stretched, the AI can actually lose track of the original words we fed it. We handle this with a safety bypass. This path loops the original input around the complex processing and merges it back into the output, ensuring the AI never loses its place. This acts as a firm save point. The model deepens its understanding without ever losing the raw sentence it started with. This chart reveals something crucial on the far left, an n times multiplier. That massive processing of attention, feed-forward processing, and normalization makes up just one single decoder block. A modern AI model repeats that exact sequence block after block, often over 100 times. With every single pass through the factory, the system's grasp of the text grows sharper. This overview shows the end of the line. The data finally hits the top of the stack, passing through a sorting stage labeled linear before entering the final probability calculator, called softmax. Softmax is essentially a massive probability calculator. It takes all the refined context and converts it into percentage-based guesses for what the single next word should be. The model isn't thinking, and it can't see the future. It just looks at the math, evaluates the options, and selects the highest percentage word. Text was translated into numbers, stamped with an order, scanned for context, and refined over dozens of passes through the factory. Based on the prompt "I am happy," the factory finishes its work and snaps perfectly onto the most likely next word, today. The Transformer Decoder is a highly organized, ultra-advanced autocomplete engine. Now that you know how the engine works, what kind of ideas would you want to build with it? Drop your thoughts in the comments below, and don't forget to subscribe for more deep dives into the systems shaping our digital world.